Okay, next problem we have Yoda dealing with Luke whining and complaining. So let's see. Part A is just how much work does Yoda have to do through the Force to lift Luke's X-wing, and the X-wing starts off at 2 kilometers, sorry, 2 meters below the surface of the swamp, and Yoda lifts it to 0.5 meters above the surface of the swamp. So the X-wing gets lifted up plus 7.00 meters. Gravity on Dagobah is 10.0 meters per second squared, because I say so. And the mass of the X-wing is 90,000 kilograms, so 90,000 kilograms, which then gets us that the work that Luke has to do, or sorry, the work that Yoda has to do to lift it is mg delta h. It's the change in potential energy he wants to get to the X-wing, assuming it starts and stops with 0 kinetic energy. So, pretty easy then. What is it? 7 times 9 is, 630,000. Multiplied by 10 again, so 6.30 million joules. So I'm going to go with, just call it megajoules. Okay, that's part A. Pretty easy. Part B, once he's lifted it out of the swamp, he wants to start it moving at a speed of 35 centimeters per second. So, force obeys conservation momentum, of course, and there's friction. There's no friction between Yoda and the ground. We neglect that. So how fast does Yoda get propelled horizontally? So very simply, massive. I'll go with massive Yoda is 1, and that's, what did I say, 60 kilograms. Mass of the X-wing is 90,000 kilograms. U1 and U2 are both 0, so they're initially motionless, and then we want the X-wing going at let's say 0.350 meters per second, which was 35 centimeters per second. So V1 is what? So very easily, initial momentum is 0, final momentum is m1 v1 plus m2 v2, which is going to be 60 kilograms times V1, whatever that may be, plus 90,000 kilograms times 0.35 meters per second. And so, let's see, what's the deal going to be here? V1 is going to be negative. We're going to have a 90,000 over 60, and that's, of course, kilograms over kilograms, times 0.35 meters per second. So really, let's see, 60,000. So it's going to be 1,500 times. So 1,500, that's what this factor at the beginning comes out to be, right? Yeah. Times 0.35 meters per second. So multiplying by 1,000, we get 350 meters per second, and 1.5 times that. So I believe the answer is 525. Actually, I'll drop my negative sign. So really it should be negative 525 meters per second should be Yoda's velocity at the end. Yep, okay. So that doesn't happen. So quite clearly, the force does not obey conservation of momentum. Thank you.